Welcome, everyone. Thanks for having me. So I want to talk today about having worked in a lot of different areas and why that's useful. So I'm a cloud robotics research scientist at iRobot. You can see from my title that my life is buzzwords. I work in robotics, I work on cloud computing, I work on the Internet of Things and the smart home, and the new hotness in cloud computing, which is called serverless. I'm an AWS serverless hero, and my doctorate is in mechanical engineering. So I've done a lot of different things. My PhD is in mechanical engineering, and yet today I'm a software developer. I do robotics. My undergraduate degree is in physics and math. So I've done a lot of different things, and I think that's been very useful in doing the things that I do today. And so I want to convince you that that's a good idea. Because you always have this decision in a career of whether you want to go for breadth of experience and expertise or for depth, right? You can be a generalist and you can learn about a lot of different things, and that opens up a lot of avenues for you. It enables you to join different fields, but you may lose out in, say, applying for a job to someone who's more focused in that area. And so there's a danger there. On the other side of the spectrum, when you're a specialist and you're focused on a single area, you have the trouble that, you need to make the decision to be a specialist very early because it takes a lot of time to build up that experience. If you're going for breadth, you get to add new things to that whenever you want. The other thing is that you may end up locked in. If you do something and you spend all of your time doing that one thing, and then later you discover, this isn't my favorite thing, you're kind of stuck. So I want to convince you that doing both is actually the best solution. So someone came up with, in like the 1990s, the idea of T-shaped skills, where you combine a broad gamut of experience and expertise that doesn't run very deep with a single focused area that you specialize in. Of course, because there's no such thing as a free lunch, you're less broad than a generalist, and you are less deep than a specialist, because you don't have the time to go as broad or the time to go as deep. But the combination of these things is useful both for people and for organizations. So I'll talk about basically why I've found that being T-shaped is useful for me. And then I'll talk a bit about the technology that I do, which is really about how to apply technology more effectively to solve business problems, and how that fits into the cloud computing paradigm that I work with, which is called serverless. How to think about how to apply those lessons to yourself as a person in a career, and the effects that that has on collaboration. So I went to a tiny undergraduate university called Hamline in the US, where I studied physics and math. Hamline is a liberal arts college where you're required to take many different classes in many different areas at the expense of the things you're getting your degree in. So I studied physics and math. I took fewer physics courses than a non-liberal arts university would require for a physics major. I've found that physics and math is a great double major because you have to take enough math and physics that it's not that much extra. But more fundamentally, I like physics and what physics has taught me because it's not really a science major when you think about it. It's, you don't spend your time memorizing facts. You spend your time learning a few underlying principles, and then all of your classes and all of your labs are around how do I derive something from this, or how do I go about figuring out how to test a hypothesis. It's teaching you a set of skills that are going to be useful if you're doing physics long term, but are also incredibly useful in any domain that you go into. Mathematics is similar, right? In the end, you're not just memorizing pieces of information that you can regurgitate later. You're learning how to think. But I also did theater. So I'm not an actor. I build things. And that's what I did for money in college. And that's an area where, unlike physics and math, it's all about creativity, it's all about art. and producing those things under a lot of constraints. In theater, there's never enough money, there's never enough time, and while it's nice to have enough money and time, you don't learn as much as when you have a lot of constraints. So I knew that I wanted to go to grad school, but I didn't know what in. And so I decided I'd get a job for a while, and I signed up with a company called Infosys, which is a giant Indian IT company. The first thing they did was send me to India for 6 months for training, which was another great horizon broadening experience. It's also a giant bureaucracy. So you are a cog in a machine that has, by now probably 100,000 employees. And so you're one small part of a very big whole. And you do contract projects. So you go and work for some other company on, for me, ranging from 100 engineers to just me. And so in contract work, while it's not the most fulfilling, you also get work applied in many different situations. So you cover a lot of ground. Now, I worked there for 2 years, and I had figured out I wanted to do robotics. So I started applying to PhD programs. And I didn't actually know much about engineering, like exactly the disciplines in engineering. So I decided to apply for mechanical engineering because I like to make things move. But it turns out that electrical engineers and even computer scientists do that as well. And I put in a lot of applications. Being from a small school that no one had ever heard of, I didn't really know what I was qualified for. So I applied for top tier schools and schools lower down on the rung. And I found that it didn't actually correspond at all to how the ranking of the school and whether I got in or not. So I got into University of California at Berkeley, but I didn't get into MIT. But then also lower down the scale, I got into some, but not into others. And so it was really taught me that it's useful to not limit yourself when you're putting in those applications, even when you're paying for an application fee. Also, when you're going to get a PhD, you're looking for funding. In a PhD, you don't want to have to pay for that out of pocket. You want them to pay you to do research or to teach. And not every school offered me funding. In particular, Berkeley, which is where I ended up going, didn't offer me funding. But I went there, I talked to professors and convinced one of them that my software engineering background would make me a good teaching assistant for the Intro to Programming course. And then I had a handshake deal to give me funding if I went there, which was good enough. It lowered my risk enough to accept there. And once I was there, I found a lab. I worked for 3 years on multi-UAV control. And so unlike the drone that was flying around in here, 10 years ago, those were not as good as they are now. And so we actually flew like fixed wing planes around, which is much harder. And now that there are quad rotor drones, I'm really jealous. But this was a lab that was like a startup. So it wasn't heavy, sort of theoretical research. It was very hands-on, working for a funding source that was asking for a single product and paying for a number of grad students on that, which meant that we were trying to deliver sort of one goal, and each of us was trying to cram our research into that goal somehow or another. And that meant everybody was working together on it, on real hardware, which is hard. If you're thinking about whether to go into sort of theory or practice in an engineering discipline, you have to really love frustration to deal with actual hardware, because you can simulate all you want and it's free, relatively. But when you're like, for us, when our planes wouldn't work, well, if they wouldn't work on the ground, it was frustrating. If they wouldn't work in the air, it was catastrophic. And what I worked on a lot was optimization-based control. And if you have an opportunity to study that, either just optimization problems in general, or optimization-based control, model predictive control, it tends to be a good orientation into good ways to think about complex problems in terms of how do you balance competing requirements, conflicting desires, how do you think about whether constraints are sharp and hard or soft, and how you plan movement through an ever-changing environment. But that lost funding, and I actually had to switch advisors in the middle of grad school, which was difficult, but not the end of the world. And I would suggest that anyone in grad school, consider that as an option if you're in a place that you don't want to be, right? Always be open to, maybe I should switch what I'm doing. Now, the lab that I joined was a really sort of T-shaped lab. It was very broad in the things that it pulled together. So we worked on art projects. We worked on a project with a museum to install sort of a speaker system that understood where people were in the room and have the sound follow around them. So there's a lot of collaboration involved in this. And this is where I started doing cloud robotics. So cloud robotics is how you can use the internet to enable robots to do more and better things. So this includes things like connecting them to humans to get them, when they're stuck, you want them to contact a human to unstick them because humans are smarter than robots. Right? Robots are good at very specific things, but when you remove them from that very specific area, they can often fail very quickly. You also connect robots to each other to help them learn collaboratively. You connect them to cloud computing resources to enable them to be much smarter than they would be with just the computing that they have on board. And for me, that meant both theory and practice. So writing papers on sort of the conceptualization of cloud robotics, what's possible with it, how it should be used, how you should think about the uncertainty of a cloud connection. And then also practice. I worked with Google to use their object recognition service to allow a robot to understand its environment and then to pick things up inside it. So the thing about cloud robotics and cloud computing in general is it's only interesting when you have scale, when you have a lot of things all connected at the same time. And so when I finished up my PhD and I was thinking about what to do next, well, I wanted to go somewhere with a lot of robots. And so I joined iRobot because we have the most robots. We've sold, I think it's at least 20, maybe 25 million Roombas to date, which is, of course, our biggest seller. We also sell mopping robots that can clean hard floors, and we just announced a lawnmower. I know most of you probably don't have lawns at the moment, but by the time it's publicly available, maybe you will. And so at iRobot, right, this is all Roombas that you buy today can be cloud connected. You don't have to connect them to the cloud. They work just fine when you push the clean button, but you can connect them to the cloud to get a better user interface, to get notifications of when they're done cleaning, those kind of things. And so I worked with that. I work on all of these topics here, all of which are high technology. And you can see through the history of the things that I've done, technology has been the thread, and I've done a lot of different things. But here's the thing, it's almost never the point. So iRobot sells the Roomba, but we don't actually sell cleaning robots. That's not what our customers are buying. Our customers are buying clean houses, right? There's this adage that, don't sell drills, sell holes. People want a hole in their wall, and they don't care exactly how they get it. So making a drill that's fancier is not necessarily a better product for what customers are looking for. We have visual navigation on our robots, and that's state of the art. And it's incredibly robust, and it enables our robots to do really cool things. You don't see that in our marketing materials because our customers don't care. They care about what it can do, and that technology feeds into the capability of the robot, which is what we talk about. But the actual way in which we accomplish it is immaterial in terms of what our customers want and how we think about accomplishing those things. So technology is a means to solve business problems where the word business can mean many different things. If you're a government, your business is policy, right? And so you can solve policy problems with technology, but the technology isn't the point. So I want to talk a little bit about how to think about that, about delivering that value to a customer and how technology fits into it. So if you're selling a product to customers, you want them to pick yours because it's better than your competitors, you hope. And when you do that, most of what you are selling is not actually different or interesting to the customer. We call that table stakes, the things that you have to provide just to play. And if you are building a mobile app, you need to have a settings page. Your settings page is not going to win you any customers. It can lose you customers. You can lose points over doing it poorly, but doing it better than anyone else doesn't help you. And that's actually most of what you're doing, right? You have login, you have settings, you have just sort of the UI flow inside an app. You have all of these things if you're building a product. The drill that we were talking about, right? It's got to have a shape, it's got to have a trigger on it, it's got to have a switch, it's got to have a battery on it. All of these things it needs, but don't actually help it do the thing better than anybody else. But there is that core value that you have, right? And that's what makes you different and better, and that's what you should care about more than anything. And it's worse than that because that's only the stuff that the customer sees. There's all this stuff that you have to do just to deliver that product to the customer that the customer doesn't care about and for the most part doesn't feed into that value that you're providing. And we call that undifferentiated heavy lifting. It's heavy lifting because it's hard work, and it's undifferentiated because it doesn't make you different from your competitors. And so when we think about this, what we want is to just make someone else do all that undifferentiated heavy lifting, right? That allows you to focus on the value because you're getting someone else to do that for you. Now, there are some things that you're not going to end up being able to outsource, that you have to do yourself, and you want to make that as sort of thin as possible. You want to say, all right, these customer-facing features, I'm going to use an open source library to provide it rather than building it myself, because that's less work for me. And that allows me to focus on the thing that provides value. And so you can see here that all of this other stuff that you're having other people do, right, again, it can lose you points. It can't win you points, but it can lose you points, which means you need to make sure that it's not bad. And to do that, you need to understand it. You need to understand what bad looks like so that you can recognize it and say, I don't want this. You're not doing it right. And to do that, you need expertise. You need some expertise in all of those areas to be able to recognize that. But you want that to be just enough to get that kind of understanding so that you can get deep expertise in that focus area. So this is really about being T-shaped as a business, right? That you have deep expertise in just that area that makes you different, and everything else you're pulling together from other places with enough understanding to make sure that it all fits together in the right way. And this is what serverless cloud computing is about, so this is what I do. To just get the background here, when you have software on servers, right? You have a web app, you need to host it somewhere. You can put it on your own machines. You can buy physical servers. They're usually not boxes like this. They're usually little thin things that go in a rack. But you own them, and you have to put an operating system on it, which you have to upgrade, right? The security of that is even more important than like the security of your laptop, which you have to, annoyingly have to upgrade all the time. You're responsible for the hardware maintenance, right? Anything that can go wrong in it, you have to replace. You're responsible for all the network that goes out to the internet provider. All the cables, all the routers, that's all you. And stuff breaks all the time, right? The more things you have, the more often something is going to break. So 15 years ago or so, cloud computing came along, and people say the cloud is just someone else's computer, and you're renting it from them. But that sort of understates the utility of cloud computing, where all of a sudden, instead of saying, I need another server because I have more traffic, instead of saying, I got to order them and wait for them to arrive and install them and set them up, I can just tell Amazon, hey, I want a server. And a minute later, I have one, and I'm off and running. This is that on-demand access, but you're still responsible. They're still handing you just a virtual server which then you have to put an operating system on. You have to put your software on top of that. You're still maintaining all of that, and stuff still breaks, right? All of those things have things that can go wrong in them. And then it's not just having servers, but knowing how to scale them up and down. As you get more traffic, you need more servers. But if you have too many servers, they're sitting idle and you're paying for them, and that's just wasted money. You don't want to overpay it. Stuff still breaks, right? So you're scaling up and down, and that scaling itself can break, right? You may not be scaling up as fast as you need to. You may not be scaling down when you need to. All of these things you have to pay attention to and manage. And stuff breaks all the time, right? When a hard drive dies, right? Which, when you have enough servers, happens all the time, just continuously. You don't want to lose the data that's on it. So you have to have several copies of this data and make sure that if one of the hard drive dies, you then spread it out to the other ones. And they can't all be on the same server. They need to be distributed amongst servers. Even worse than that, you need to put them between different data centers to make sure that if something happens to the whole data center, it's still OK. And that's hard. That's, people do PhD theses on those kind of problems. So once you solve that problem, at the very least, for the rest of the things you're doing, you can make it stateless. You can make a web server that there's a database that deals with keeping the data safe. So your web server, everything that it does that has to be stored, it goes to the database to do it. And that's going to help you do that. But here's the thing. How does knowing how to do any of this help my business goals? How does doing any of those things that I talked about help iRobot make cleaner houses? And the answer is, right, it doesn't. Technology is not the point. So this is where serverless cloud computing comes along. And the first thing we have is software as a service, right? So this is saying, let someone else do it. Buy a service for the software that you're doing, right? Whole applications are like Google Docs, right? Microsoft Word today is now much more like Google Docs, but say 5 years ago, you had to buy Word, you had to install it on your computer, you had to keep it up to date, and all the files you saved were local. You could lose them if something happened to your laptop. Google Docs comes along and says it's automatically updating. Whenever you go to it, you get the latest version. All of your documents are saved in the cloud. And so there are applications that exist at that level, but we can have those building blocks as a service as well. So you can have a database as a service, which gives you an interface to say, here, hang on to this for me. And the provider for that database service, like Amazon, takes care of all of those complicated things that we talked about, right? So that when you go and say, take this thing, they never say, sorry, I don't have enough capacity, or sorry, I don't have enough servers running to let you, to take it from you, or sorry, that got deleted somewhere because something bad happened. All of those things are taken care of for you, and you just pay for the usage that you're giving, right? And we do this with passing data around in the cloud, not just storing it. We do this with logins, right? When you use login through Facebook on a website that's not Facebook, that's that website saying, I don't want to have to do login. I don't want to have to own user accounts. They don't have to keep your password safe. That's Facebook's problem, right? So that's outsourcing those pieces so that they can focus on the core experience that they're trying to provide you. So serverless cloud computing says, use software as a service for everything you can do, and where you can't, use functions as a service. Now, people hate this name, and it's terrible, but we're stuck with it. I can't do anything about it. So the idea is that, sure, there are servers for those database services that you're using, but you don't have to care about them. You don't have to care how many there are. You don't have to care if they're running or not. All of that is hidden from you. In the same way that wireless charging still has wires from the mat to the power outlet, but the part that you care about, which is between your phone and the mat, doesn't have any wires. That's why we call it wireless charging. That's what serverless cloud computing is like, right? And so where you can't use software as a service, where there doesn't exist a service to do the thing you're trying to do, you use this thing called functions as a service. And so this is where either there just doesn't exist a service because someone hasn't figured out how to make it yet, or it's the thing that you're trying to do. If someone made a service for the thing that you're trying to do as a business, you shouldn't be in business because someone already made it a service. So functions as a service is this thing where we take your source code and you hand it to somebody and you say, run this when certain events occur. So when someone makes a request over the web to this endpoint, run this code with the request, and whatever the response is from that code, give it back to them. Or whenever somebody changes a record in the database, run an event that takes as input the change that was made so that I can do something with it. This is all stateless. The code that you write and hand over can't store any state itself locally. It has to use a service to store state. And it's time limited. Your code can only run for a couple of minutes at most. A canonical example of this service is AWS Lambda, which does exactly this. There are similar things on the Google Cloud, on Microsoft Azure, and various other sort of open source projects. The combination of being stateless and time limited allow the scaling and maintenance to happen from the provider. So this was the real change that happened in it was really 2015 that this came about. That before then, there were these things called platform as a service, which allowed you to put code on a server and it would run for you. Google App Engine was this, Heroku is this. But they require you to say, this is how many servers I want. And every once in a while, they'll say, sorry, we have to recycle this server because we're doing an upgrade on it. Once you're time limited and stateless, each time an event happens, it gets its own little instance of the code running. And because it's time limited, it's going to end. So a server that needs to get upgraded, you just say, I'm going to stop accepting events on this server. They can go to other servers. And eventually, those time limits run out. Nothing is running on that machine, and the provider can do whatever they want with it. They can upgrade it. They can shut it down. And that's all transparent to the user. The user doesn't have to say, oh, you're doing a maintenance window. I have to take some action on this. The other thing is, because these run only when events come in, you only pay when you're processing data. And this is really powerful because now you don't have to worry about the scaling, right? You don't have to say, this is how many I need. You just say, however many events come in, run that many things and charge me for it. And this is useful, right, for a business as, I'm not overpaying. This is also useful in academia. We're seeing this get used because you don't have to buy a bunch of computing power and run it for hours at a time and get charged for that. You can stand up, you can use this kind of framework for running code to do big data processing without a lot of cost. All of this is in service of letting you focus, right? You're using these managed services for everything you possibly can. And you're writing very little code to glue all of those services together. And that code is then only what matters, right? It's the things that you do that's different from everybody else. You're paying for only what you use, so you're not worrying about how do I make sure that I'm using this stuff effectively. And your scaling is easy. You're not worried about what's going to happen when, I get a good news article and I get 10x the traffic that I normally have, right? All of that is just taken care of for you, and you can focus on writing features. So if we go back to this, right, this diagram, serverless is about using managed services for everything but that focus area, which is where you're writing your own code. And so, well, as software engineers, we like writing code. The less code we can write, the better. We shouldn't measure our productivity in lines of code written, but rather number of features shipped, right? How much value are you creating over in that box? Not how much coverage of this whole thing do you get, right? You shouldn't really get points for doing anything outside of that box. So the way this has helped us at iRobot is that in 2015, we launched our first connected Roomba, right? This was the Roomba 980. And so we have a long history of making robots. iRobot was founded in 1990. Roomba's been around since 2002, so this was more than 10 years of Roomba. And 10 years into Roomba, there were 4 software engineers working on it, right? There was not much code running on that robot. But all of a sudden, we wanted to open that up and say, what can we do once this has a cloud connection? What can we do once we can provide more features through the cloud? We can provide firmware updates to update it over time. We can provide a mobile interface to it. Because you can schedule Roombas, but before they were connected, you had to do all of that through the robot itself, which doesn't have a screen. So there's 4 buttons on it with which you had to set the time and then set the schedule, and all of that is communicated just through beeps. There's no numbers that you can see, no nothing, right? That's terrible. Now you open up your app, you go to a screen, and it shows you your schedule for the week, and it's easy, right? All of that we gained through cloud connection. But we weren't there yet. We had built military robots that were network connected, so we had experience with making networked robots. We had even built telepresence robots that had a cloud connection, so each customer, which were large corporations, got their own private cloud, which was a set of servers installed in some rack somewhere. So we weren't on the hook to build sort of scalable systems. There weren't huge numbers of these robots out in the wild, not like Roomba volumes. And of course, now we're connected through our entire line of Roombas, right? And we knew that that was coming. And we sell millions of robots a year, so we knew that this scale was coming. But back in 2015, we were trying to figure out how do we launch this, right? And so we first took the approach of saying, well, let's outsource it. It's not what we currently do as a core thing. So let's get someone else to do it. And we contracted with a full solution IoT cloud provider. So they provided the cloud connection, they provided the firmware update, they provided a little coding environment for you to do sort of custom things. And it seemed like a good idea at the time. But as we were nearing launch, we realized that the scale that they had promised us wasn't going to materialize, that at Roomba volumes, it was just going to fall over. It was actually one of my first tasks at iRobot was that we didn't trust them, what they were saying. So I had to build a load tester to test high volumes of simulated robots hitting this. And we repeatedly set their systems on fire, which was fun. But also prove to them, oh, the thing that you've promised to us in writing, in a contract, you're not going to deliver. So we wanted to move off of them. And as we thought about this, right, we had started at the place where we said, we don't want to own any of this, we'll just get someone else to do it. But we knew that this connected Roomba was part of our journey into the smart home, right? And so in changing the IoT cloud provider, we were a hardware company. And like I said, a couple years before this, we were at 4 software engineers, and we're in the hundreds at this point. So at that point, we knew that all of a sudden our software trajectory was vastly different from what it had been in the past, and that this connected part was going to be an important part of the broader story of our company. And so that meant, well, we wanted to own some of it. We wanted to own our destiny in the cloud. But we wanted to figure out what didn't we have to own. And so we looked at Amazon, and we talked with them. This was 2015, and AWS Lambda, that functions as a service had come out, and we looked at the offerings that they had, and we said, we think we can build all of this on AWS without running any servers. And that has been really, really successful. So we've had this in production for a couple of years on Christmas. So Christmas is a fun time for iRobot because it's our biggest selling season. And in the US, there's Black Friday, which is right at the end of November. And all the robots that are sold between then and Christmas, everybody opens them on Christmas morning all at the same time. So unlike Amazon has Prime Day, that's another big seller for us, where lots of robots get sold, but they arrive in differing amounts of time. People don't open them right away. So the sales are high on Prime Day, but then our bump in actual registrations of online robots is kind of spread out. For Christmas, not only is it our biggest selling season overall, but all the robots that are sold, they all come online in about a 6-hour period overall, but about 3 or 4 hours in the US, which is our biggest market. And so it's a massive influx of robots. And if we were running this on servers, we would have 15 or 20 people all paying close attention on Christmas morning to exactly what's happening and probably having to fix all sorts of things, right? It would be a very stressful time. We had one person who was paying attention to it, and they had to, they tweaked a knob sort of up as the amount of traffic came in. They didn't really need to. It would have backed up some things that we wouldn't have processed for a couple of days. But it was essentially, like, it's a non-event for us now. Like, it just doesn't, it's not a big deal. And that means that all of those people that we would have to have hired to do that work can now actually be software engineers working on things that customers will see, right? And that's what's powerful for us, is the ability to apply all those resources instead of to that undifferentiated heavy lifting, all that stuff that's underneath that can lose you points but can't win you points, is now all applied towards the actual value that you're providing to the customer. And that's because we don't sell cleaning robots, we sell clean houses, we especially don't sell cloud applications, right? Our customers, they're vaguely aware that the cloud is there. They know that the app connects to the robot. They don't care how. They don't care how we deliver it. They just care that it works. So now I want to talk about how to turn this around and think about how it applies to yourself in a career, right? Because when we move from this sort of business value to personal value concept, right, you want to focus on things that you're providing to a customer, but then there's all sorts of other stuff that somebody cares about, right? So first, who are your customers, right? Well, they could be actual customers, but they're also your employer, right? Your employer, you're providing value to them, and they're paying you for it, right? You want to figure out how to deliver that value as effectively as possible to make yourself a valuable employee, so that you can make more money or get a promotion, any of those things, right? Your colleagues are also customers of yours. Anyone who is looking to you to provide value is a customer, right? And you want to figure out how to provide that value effectively so that you work better with people, right? And so as we think back to this, when someone is looking to you to provide something, it's rare that you can provide that all on your own. There's some key piece of it that you have to provide, that you're there for, and that's that thing that you want to focus on. And you need to work with other people, otherwise it's the overall product that you're looking to create, right? The thing that it is that you're trying to deliver isn't there, but you don't want to have to try and do everything. You want to be able to do the thing that you're good at. But you still need to understand the rest of that picture to know that the thing that you're contributing is the right thing and that it all fits together correctly. So my experience has fed into this, and this is where I think being sort of T-shaped is useful, having a broad background of experience. In theater, as a technician, right, as not an artist, but a technician, a person who's building the things, you get the artistic people, the director or the scenic designer, coming to you and saying, like, this wall, I need it to look drippy, like a waterfall, but not wet. And you can look at them and you can say, that doesn't make any sense. That's the dumbest thing I've ever heard. But that's not your job. Your job is to make whatever it is they have in mind real. And the trick is that what they have in mind is not necessarily concrete yet. They may have some vague conception, and they don't know how to turn it into something real, because that's your job. That's the value that you're providing. That's the unique thing that you can provide that they can't. And so you may say, like, I don't know, a candle, like a candle that's gone out is drippy, but it's not wet, right? Does that work for you? And they may say, yes, that's exactly what I want. Or they may say, like, no, that's not it at all. And you say, I don't know, lava it drips, but it's not wet. Does that work? And so you go through this process and you extract out of them the meaning that you want, or not that you want, that they want. And then you create it. And sometimes you have to say, like, no, that's not physically possible. Or we could do it, but the actors would hurt themselves. You have all of these constraints that you have to navigate and work with them, but you can't necessarily say like, you can say that's physically impossible, we can't do it. You can also say, well, we could do it, but it's going to blow half our budget, and all this other stuff is going to have to go away. And they may say, yes, that's worth it. And so it's your job to, again, help with that optimization problem of saying, what is it that you want? What are our constraints? What are our trade-offs? And help deliver it. So then when I went into contracting, that was immensely useful. Because your client, when you're a contractor, comes to you and tells you that they want something, and they don't know everything that they want, or they don't know how hard it will be or how much it will cost. And it's your job to help work with them to figure it out, right? And to pull together as a contracting team that has different expertise, right? Because when you're contracted to do a piece of work, it's not, I need a person that can do this, I need a person that can do this, I need a person that can do this. It's, I need a product that can do this. And the contractor goes and says, all right, well, we need these different people who can provide the things that that product needs. At iRobot, this has been a useful skill for me too, right? The ability to go across the robot, the cloud, and the app, all of these pieces that we have to pull together to provide a smart home user experience are things that I work across to help deliver the customer-facing features. So I want to talk about how this feeds into collaboration and having that broad understanding, because when you understand something, right, if this is the sum total of your knowledge, and if you're T-shaped, right, there's some core of it that's your depth of experience. But when you're working with someone, you're going to overlap with them in your understanding. But there's going to be things that they know about that you don't know about. And you want to keep that in mind, right, that they understand things that you don't. You understand things that they don't. And there's some overlap in which you may have equal understanding or unbalanced understanding, right? This picture can be a lot more complex to represent all of the actual combinations that you have. And when you're working with more people, you start to build, overlaps in complicated ways. People who understand things together that you don't, who don't know things, but you know both of them, right? And it only gets more complicated as it goes. And one of the perils of working in an environment that's collaborative is that sometimes you look at the sum total of the things that you don't know, and you feel like everybody knows those things. And you only have this small little piece in the middle. And this gets called Impostor Syndrome, where you feel like, everyone is way better at their jobs than you and understands all these things, and you don't understand much, and it's only a matter of time before everyone figures out that you don't know anything. And it's because you're taking this picture, right? And all the things that you know that you don't know, you don't necessarily know who knows them and who doesn't understand them, right? Now, on the flip side of this, all of those things that are outside of your understanding, sometimes you lose sight of that, and you think, oh, well, these things that these people are collaborating with me on, I understand those things, the parts that overlap with their parts, and I understand all of it. There's nothing that they know that I don't know. And I've experienced this happens with PhDs sometimes. So there are two types of people at the end of a PhD. They're the people who, right, a PhD is all about focusing on one very narrow area and learning more about it than anybody else in the world, right? Your PhD thesis is supposed to be new knowledge, something that no one has ever done before. And I think most people, they get to the end of a PhD and they look at it and they say, wow, this subject that I spent 5 years on has all of this depth, right? And it's not unique. It's not the only subject that has this. All of the things, like everything you encounter must have that level of depth in it. And I don't know any of that depth, right? So I have this one narrow area of experience, and all of these things people must know so much more about than I do. And then there's another type of person who looks at that and says, I've spent 5 years on this, and I'm really good at it. I must be good at everything. Don't be that person, and try not, if you can avoid those people, it's helpful to avoid those people. Because when you're collaborating with someone, right, what you want is to be effective at delivering the thing that you're working together on. And to do that, neither of you has the whole piece. And so having an understanding of how do I find out what this person knows about and how my understanding of it can grow with them, right? Understanding, you know, I need to see that what they're doing fits with my piece, and they have constraints that I don't necessarily have, right? This comes up a lot in situations in companies, right? Where you're working and, you know, the finance office doesn't let anybody pay for stuff on their own. And it's really frustrating because anytime you want to buy stuff, you have to go to them and you have to ask them for it. And you know that everything that you're working on is worthwhile. So why do they have to do this to keep you in? And from their perspective, right, there may be parts of the company that don't spend money wisely and that can't be trusted, right? And it's easier for them to just then have a blanket policy of say, you got to come here and we'll check it because we don't know who to trust and who not to. And it's too much time to work that out, right? And so from their perspective, it's, you know, their incentives, which are make sure that money is spent wisely, causes them to act in a way that's contrary to your purposes, which is, I want to get this thing out the door as quick as possible, right? And even within, you know, an engineering team, you may have the people who are focused on how do I make the best possible product? And someone else may be focused on how do I make the most profitable product? And those are not the same thing, right? Features that may make the product better may be too expensive for the profit margin that you need. And so you want to figure out what people's goals are and what their incentives are to understand all the things that are happening because of the stuff you don't see. And that will help you work better with other people, right? And as you work with more people, it becomes complicated because you may be the bridge between multiple people, right? You may have understanding that bridges two people who don't know anything about what each other are doing. And if you can work to have skills to expand that, that's going to help you in your career. And being T-shaped is all about sort of spreading that circle as wide as possible so that you can more effectively work with people. Because as you're building teams, right, if you build a team of specialists, you build up this core competency, but collaboration can be difficult because there isn't a lot of shared understanding between members of the team. But also if you're reliant on each member of that team for everything in their domain, right? This is a chain is only as strong as its weakest link. But if you're building teams with T-shaped skills, right, when you add another person, there's overlap. And there's enough understanding there where, you know, if this green person is building something, they're not required to maintain it. Someone who's got some overlap there can understand it well enough to use it, right? And that only builds as you go out. It's more like building your team like ropes. Ropes are stronger than their weakest strand. And so building this, right, is all about being curious about what other people know and what other things there are to do. It's about building empathy, right? That the more you understand of how other people think and how other people behave and what they know, the better you'll be able to collaborate with them. Having extracurriculars, especially that are related to your core discipline, is helpful. It helps you sort of build into a funnel shape where the things that are in your core competency feed into the adjacent areas. And the things you learn in your adjacent areas can help inform the depth that you have. And I would say always be open to changing disciplines, especially early on, where you may find that a lot more skills transfer, even if the facts don't, between different disciplines. So to sum up, right, my argument here is saying that T-shaped skills are useful for both people and for organizations, right? That having breadth and depth is important, even at the cost of both, right? And that really importantly, as technology students, remember that technology is the point. Now, if you go into academia and you are researching technology, then technology is the point. If you are a software as a service provider, then technology is the point. But the vast number of situations that you're going to be in, technology is not the point. It's a means to an end. And the better that you can be a technologist that leverages technology to achieve other goals, the better you're going to do. Serverless computing is, I think, the best way to achieve that in cloud computing. And so with that, I'll take questions if anyone has any. In the back.
Does anybody have questions?
There's somebody in the back there.
Hey there.
Hi.
Yeah, I have a specific question because I was looking at iRobot.
Yes.
And why is it circular and not like a square shape?
Yes.
I had this question about like a competitor of yours, the
Yep.
Xiaomi something.
Yeah, so the trade-off between round and square front is it's easier to make a circular robot because a circular robot can turn in place and never hit anything. It means that it's always going to be able to escape from any place that it's in because it can always just turn in place and leave. A square front robot has the advantage that the brush underneath can go all the way across so that it can more effectively clean. And so there's a trade-off to be made, and Roomba being, having started in 2002 when the amount of software that had to be written was high, went with a circular design to simplify a lot of those problems. That was one of those things of making the decision, this is going to get the product out faster, this is going to accomplish the solution in a good enough way. And we at iRobot have taken that and said, okay, well, within this circular design, how do we improve cleaning? How do we do those things? It's the same trade-off to be made between cameras and lasers. So lasers are on some products, and they give you an instant picture of exactly what the floor looks like at the height of the robot. And it's really great, but it only tells you exactly where the wall is at that height. A camera tells you a lot more about the environment. It gives you a lot more richer information, but it's a lot harder to turn that into a map of the floor. And so we at iRobot looked at that and said sort of the opposite thing. We said, for this situation, we think that a camera is going to provide a lot richer information that within the smart home is going to be valuable. So the ability to say, like, I saw a refrigerator and an oven in this room, this is the kitchen, is useful to us in a way that a laser wouldn't provide. And so doing the extra work of visual navigation was worth it for those reasons. Any other questions? Yeah?
Do you have any reason, sorry, on why to use Amazon serverless functions instead of Microsoft or Google?
Yeah, so we chose Amazon for two reasons. We wanted to build on Amazon as it's, the leading cloud provider, has the widest selection of services. And then we also chose AWS IoT as our cloud connection. So the robots, when they connect to the cloud, they use this AWS IoT service to do so. And then behind that, we also built on AWS. We didn't have to. We could have swapped out either one of those to be something different. So Google, iRobot is a long-running, profitable company. And so makes decisions based on, is this company going to be around for a long time? All of those kind of things. Google has a habit of shutting down services that they run. And one of the consequences of that is that if you build something using a certain Google service and they decide to shut it down, all of a sudden you have more work to do because you have to replace it with something else. right? Usually Google does this because there are other options that they have, but it still means that you have work to do that isn't helping your customers, right? Amazon does not do that. Amazon has a service that they built in the very early days called SimpleDB that, it's hard to find the documentation for now. Basically, no one uses it for anything new and hasn't for a very long time, but they haven't shut it down. There are people who still use it, who built with it 10 years ago, and are still using it today. And Amazon keeps that running because they know that that's important to companies. So that's an important thing. Now, on the other hand, if you're a startup, right, most startups fail. So the risk that you're not going to be in business in a year is higher than the risk you're taking on choosing Google or choosing another startup providing a cloud service, right? So that's why, that's one of the reasons that we chose Amazon. Another reason is just that Amazon has so many more services, right? There's so much more to choose from on AWS than on any of the other platforms. Microsoft is probably second. Google has a lot of nice machine learning features, but Amazon is catching up. And it's sort of, when you can get everything in one place, it's easier to do that. Now, Google's Firebase suite is actually quite useful for something like a mobile app. Like it's kind of a one-stop shop for all the things you need for a relatively normal mobile app, and is a decent choice. AWS has a sort of package called Amplify that helps do the same thing. It's not, it's getting better and better, but it's still not quite where Firebase is. All right.
Sorry.
Oh.
Thanks for the talk. So just like any piece of technology, serverless isn't an answer for everything. And there are a bunch of limitations that any function as a service stuff has. What kind of problems have you run into or limitations have you run into, especially regarding latency issues, for example, because it's up to the cloud provider to basically choose where your servers are being run, which means that they can run it on a machine that is on a previous architecture or on a new architecture, which means you will have a latency variation. Do you run into these kind of things, or is it not really important? Or are there any other limitations that you have run into?
So there are two things. One is that for iRobot, like latency is not a particularly sensitive issue for us. A lot of the things that users do are communication back and forth to the robot, and the robot may not be on, like, your Wi-Fi might be out. Maybe you put the dock where the Wi-Fi is bad. It's not really able to communicate. So there are a lot of other issues that can get in the way that we can't do anything about, that latency doesn't, so that latency isn't super important for us. That doesn't mean it isn't important for other applications. And serverless comes with a cost because of the abstraction, right? That because you're using different services, different managed services, you're always incurring network hops in between things, and that latency can build up. At the same time, what you really want to look at is the total cost of ownership of serverless versus other options. So a question is, sure, you may be able to shave 50 milliseconds off your response time. How many fewer features will you ship in a year to get that 50 milliseconds? And is it worth it? The answer can be yes, right? For Google found very early on that core to its user experience was speed. That very small increases in time of the google.com homepage affected users' perception of it very negatively. And so they poured everything into speed, and that was absolutely worth it for them, even before they had the kind of scale that makes it worth it for them today. But most people aren't Google, right? And so it's one of those questions of what's the opportunity cost for building these other things? It's also something that, it isn't too bad. I saw a comparison just this week of, it was API Gateway, which is the sort of web server layer, to Lambda to DynamoDB versus API Gateway using its service integration direct to DynamoDB versus a service running on ECS, so in containers. And the differences were there, but not enough to really care about unless it's a particular issue. Now, if you are using a microservices approach where you have a lot of communication in between, so that when the user makes one request, it results in a lot of other requests, that latency can build up. The other thing is I expect it to get better over time, right? Without us having to do anything. That's one of the benefits of serverless is something happens and everything works better, and you don't have to do a thing to take advantage of it. It just works. And so in general, I think the overall cost of going serverless, because there are other issues too, which I'm happy to talk about, you lose observability, right? So when we launched with AWS IoT, they had only so many metrics that could say what was happening in the service. How many messages were coming in per second, and how many throttling events were happening, and things like that. And they were like, I don't know, 5 at launch. And there were many issues that could happen, either because AWS was having an incident or because we were doing something that was causing something to go poorly, but we couldn't see it happening. So the evidence would happen somewhere else, but it would take time to track it down to the source. Now, and you have to make a decision to use something or not based on what it is today and what it might become. And we knew that, sure, that's only that many metrics today, but now it's got, I don't know, 60 or something, like just a huge number. And there's all of those things we can see today and make sure that things are going smoothly. But we made the decision that that's going to be worth it. That pain is worth it relative to, especially the fact that if we're doing it ourselves, and in general, if you were doing it yourselves versus using a service from Amazon, you're going to have more frequent outages, and those outages are going to take longer to resolve because it's not your business to be good at that. Whereas for Amazon, it is their business to be good at that. So that's, unless it's a very specific business need, I tend to say serverless by default.
Thanks.
No more questions?
Oh, one more in the back. Same guy. I'm also happy to chat afterwards.
One last question. How do you deal with the Xiaomi competition?
Say it again? The Xiaomi competition.
Yeah, the Xiaomi competition. Are they better at like basic manufacturing costs? Like, do they have lower manufacturing costs due to their geopolitical?
Well, they certainly have lower development costs because a lot of what they're doing is copying. But the other thing is they're making different trade-offs with respect to like build quality. So one of the things about an iRobot product is that, first of all, we design for it to last for several years, and we also make replaceable parts. So if your battery stops holding a charge as well, you can buy a new battery. You can buy new wheel modules, right? You can buy new brushes. So we design it to provide sort of a long-term experience to our customers. And Xiaomi robots just aren't built that way, right? And that might be okay, right? If it's going to work for you for a year and a half and then break and you're going to buy a new one, and that's what you want to do, that's a trade-off that customers can make. All right. Thanks, everyone.